Alright, we're going to make this pretty simple, cut and dry. Now, I'm using this function, x to the third minus 4x squared plus 4x. That was from the previous 4 example, this is the first one. Now, roll out the factor form, x times x minus 2 to the second power. So that means that x minus 2 has a multiplicity of 2. So what we're going to talk about is how is it related to the graph. So here, now keep in mind that this x right here has an invisible 1. Now the reason I mention this is because we're going to talk about how the multiplicities or the exponents, how it impacts the graph. So now we see that x minus 2 to the second power, that basically means the zeros. So let me write out the zeros here. So we have x, so x equal 0, and then x equal, and we saw this before, so x minus 2 is just simply x equals 2 with the multiplicity of 2. And that 2 is from this exponent. So, okay. We see that x equals 1. Just repeat it one time. We see that it crosses the graph where x is 0. Now, let's take a look at where x equals 2. So, when it's x minus 2 to the second power, or x equals 2 with a multiplicity of 2, we see that it turned, and then when it goes towards where x equals 2, it touches but doesn't cross. So it touches and go back up. So what happened is that it didn't cross, so it's tangent. So let me write out the word tangent. So what happens is that the graph crosses at x equals 0, but is tangent at x equals 2. So tangent means that it will touch it but won't cross it. So as you can see here, coming towards x equals 2, touches the x-axis but goes back up, doesn't cross. Unlike over here, x equals 0, it does cross. So it's not tangent but crosses. Over here, tangent but does not cross. Now we're going to see all the other examples, what I mean by multiplicity of like 2, 3, 4, and so on. Alrighty, so our second example, I'm using the same function that we did in the previous 4 sets of the factoring zeros. Now, I wrote it in factor form, so x times x plus 1 squared. Again, this is the factors for x to the third plus 2x squared plus x. And here's the factor form. Now, it's just similar to the last example where we have x plus 1 to the second power. So, our zeros are x equals 0 and x equals negative 1 with the multiplicity of 2. So, let's take a look. In this graph, we see that same thing as before. At x equals 0, it crosses the x-axis. But let's take a look at x equals negative 1. Over here, it didn't cross, it just goes towards it, touch the x-axis where x equals negative 1, and then go back down. So here, multiplicity of 2 at x equals negative 1, so that means that it's going to be tangent to negative 1. So again, tangent. So let me write right here. So tangent. So at x equals 0, it crosses the x-axis, but when it's at negative 1, with a multiplicity of 2, so over here, goes towards it, touch it, but goes back down. So it doesn't cross the x-axis. So let's review. At x equals 0, crosses at x equals 0, but not tangent. At x equals negative 1, it is tangent, but does not cross the x-axis. So there seems to be a pattern. Now let's see what happens when the exponents, like these, are odd. Alright, example 3. So we have f of x equals x to the 4th plus 6x to the 3rd plus 6x squared plus 8x. Just like example 3 of the last 4 that we did when finding zeros. And then here's the factor form. X times x plus 2 to the 3rd power. So that means it was x plus 2 times x plus 2 times x plus 2. Now I wrote out the zeros here. X equals 0 and then x equals -2 with the multiplicity of 3. Let's not focus about the bottom part here, but let's see the graph. So at x equals 0, we see that it crosses the x-axis right here. And then at x equals -2, we also see that it crosses at -2, but it looked like a little bit of vertical line. So just like in 1.4, you could say that this is a point of inflection because at x equals -2, we see that if we zoom in, it's horizontal. So here, also known as point of inflection. But don't have to worry about that. Again, that was just related to 1.4 extrema. This is point of inflection. But at the end, it still crosses the x-axis where it's -2. So there seems to be a pattern. Crosses at x equals 0, crosses at x equals -2. So now let's look at this part right here. We see that x equals 0, I wrote multiplicity of 1, meaning that it repeated one time. And then x equals -2, multiplicity of 3. So it means that it repeated, the zeros repeated 3 times. X equals -2 repeated 3 times. Or right here, x plus 2 repeated 3 times. X plus 2 plus x plus 2 plus x plus 2. So there seems to be a pattern. Multiplicity of 1, multiplicity of 3. Something in common with these two, that these two are odd numbers. Would that be the same for the next example? Let's take a look at that. Alright, we got our fourth last example here. We have f of x equals x to the 4th minus 6x to the 3rd plus x squared, 12x squared minus 8x. And then the factor form of it is just x times x minus 2 to the 3rd power. So, just like in example 3, I wrote out the 0, so x equals 0 from there, and then x equals 2 from here with the multiplicity of 3. So let's take a look at the graph. At x equals 0, we see that it crosses the x-axis. And then at x equals 2, we see that it's a bit like a point of inflection, horizontal here, but it still crosses at x equals 2. So let's look at it further down. So x equals 0 with the multiplicity of 1, and then x equals 2 multiplicity of 3. So again, the multiplicity is, if it's odd, it seems it crosses the x-axis. So there might be a pattern versus multiplicity of even numbers and multiplicity of odd numbers. So in this case, when it's multiplicity of 1, multiplicity of 3, there might be a pattern where the graph crosses the x-axis. So x equals 0, it crosses there, and then x equals 2, it crosses there, and then the common thing is multiplicity of 1, multiplicity of 3, odd numbers. So let's go over like what would be the difference between multiplicity of even numbers and multiplicity of odd numbers. Okay, so in summary, when we have factors where such like x minus c to the n power, so we gotta think about it. Like in the last, for example, we had multiplicity of 3, multiplicity of 1, multiplicity of 2. Now, keep in mind that over here, c can be any number. So I wrote out x minus c equals 0, where we would solve, and you would get x equals c. So it's just the same thing as x minus 2. When you solve for it, you're going to get x equals 2. Or x minus 3, you're going to solve where x equals 3. Or x plus 5, when you solve for it, you're going to get x equals -5. So, but let's talk about the n right here, the multiplicity. So if n is odd, the graph will cross the x-axis at x equals c. So when you have a multiplicity of 3, multiplicity of 5, or multiplicity of 1, so let's take a look. In these two graphs right here, we see that both of them, that they cross it at x equals 0 with the multiplicity of 1, and then it also crosses at here -2, and then on my left +2 when the multiplicity was 3. So again, the pattern is when you have an odd multiplicity or odd exponent for a factor, like here multiplicity of 3, multiplicity of 5, or multiplicity of 1, it will cross the x-axis at x equals c. Now, if it is even, so for example, n is even, the graph is tangent to the x-axis at x equals c. So tangent, again, these two graphs right here, we see in this left one is tangent where it's at 2, and then over here where it's tangent at -1. So again, it does not cross the x-axis, it touches, and then it goes back down or go back up. So in these two graphs right here, which you already have, these two are example where the graph is tangent to the x-axis. Right here, tangent at 2, and then right here, tangent at -1. So when n is even, it will be tangent at the x-axis, x equals c. So multiplicity of 2, multiplicity of 4, multiplicity of 6. So review, when n is odd, crosses the x-axis at x equals c. When n is even, graph is tangent to the x-axis at x equals c.